All right, so for the first one, you should have gotten 1 over 45. 1 over 45. All right. For number 2, r to the negative 5 taken to the negative 4, you should have gotten r to the 20th. R to the 20th. 2x to the 5th times 3x to the 12th, 6x to the 17th. And number 4, mn to the negative 4 divided by p to the 0, q to the negative 2, mq squared over n to the 4th. All right, let's look at 4 together. Look at number 4 together. We have mn to the negative 4th over p to the 0, q to the negative 2. All right. So we are going to look at, does anything combine? None of these combine because none of these are like bases. So now we're going to look and see what is going to change. And so we have a negative here with our n, which means that's going to move it. And we also have a negative with our q, which means that is going to move that as well. All right, so we're going to end up, the m is not going to change at all. It's to the first power. It cannot combine. It doesn't move. The q is a negative exponent in the denominator, so it is going to move to the numerator position. The n is a negative in the numerator, so it is going to move to the denominator with a positive. And then the p, anything to the 0 power is what? 1. And so you don't really even have to write the 1, but there's the 1. They did not write it in the final answer. All right, so number 5, a squared b to the 0 times a to the negative 3 is 1 over a. 3 squared to the negative 1, 4m squared to the 3rd power is 64m to the 6th over 9. 2m cubed times 3m to the 6th is 6m to the 9th. And 3t squared cubed times 2t to the 0 to the negative 3 is 27t to the 6th over 8. Division property of exponents. Division property of exponents here. All right, so the division property is taken again from expanded form. So if I were to look at the example that they gave me here with the expanded form, I would do 5 to the 6th is written 5 times 5, 6 times. And then I put that over 5 squared. And what you can do with these is you can actually cancel out 1 to 1. So I can cancel out 1 5 for every 1 5. And I end up with 5 to the 4th. And so what you'll see that starts happening with division is this property that they give us right there in the middle of the page. For every non-zero number a and integers m and n, if you have like bases, a to the m over a to the n, then you subtract those exponents. And they give the example here. 3 to the 7th over 3 to the 3rd equals 3 to the 7 minus 3, or 3 to the 4th, which is what happened here. When we did this at the top, we had 5 to the 6 minus 2, which gave us 5 to the 4th. So let's look at example 1. They want us to simplify each expression. We have a to the 6th divided by a to the 14th. So we are going to subtract those. A to the 6th minus 14 is a to the negative 8. We can simplify that more. A negative exponent will move it. Right now it's in a numerator position, so that's the same thing as 1 over a to the 8th. Another way I like to do this is you can look at your like bases, and wherever your larger exponent is, that is where your variable will be. So the larger exponent was in the denominator, and you can see the a ended up in the denominator. And so if you were to just look at these, you can say, oh, I know the a is going to be in the denominator because that's where I have more of my a's. And then just subtract 14 and 6, which gives you your 8. All right, let's look at the next one. It's a little more complicated. We have like bases with our c's and we have like bases with our d's. So we're going to do those individually. We're going to say c to the negative 1 minus 5 and d to the 3 minus negative 4. All right. C to the negative 1 minus 5. Negative 1 minus 5 gives me negative 6. So I have c to the negative 6. For my d, I have 3 minus a negative 4, which is the same thing as plus a positive 4. So I have d to the 7th. And we want to simplify that one more time because we have a negative exponent. The d does not change, d to the 7th. The c goes to the denominator. If I look at the other method here, for my c, my larger number is in the denominator. 5 minus a negative 1 is 6. If I look at d, 3 is bigger than negative 4, and d ended up in the numerator. 3 minus negative 4 gave us a 7. And so you can see from the beginning that your c should end up in the denominator, which is where it did, and that your d should end up in the numerator is also what happened. So go ahead and try those 5. Check understanding number 1, all 5 of them. All right, for A, b to the 4th over b to the 9th, you should end up with 1 over b to the 5th. Z to the 10th over z to the 5th, you should have ended up with z to the 5th. A squared b over a to the 4th, b cubed is 1 over a squared b squared. M to the negative 1, n squared over m cubed n is n over m to the 4th. X squared y to the negative 1, z 4th over x y to the 4th, z to the negative 3rd. X z to the 7th over y to the 5th. X z to the 7th over y to the 5th. There. So for this last one, we have several variables. So we are going to look at them individually. So we're going to look at the x's first. For the x's, we have x to the 2nd minus x to the 1st. So we're going to say 2 minus 1 there. For the y's, we are going to say y to the negative 1 minus 4. And then for our z's, we will have z to the 4 minus negative 3. And so for our x's, 2 minus 1 gives us just x to the 1st power. Negative 1 minus 4 is negative 5. And 4 minus a negative 3 is 7. So if we look at this one, we're going to have 2 positive exponents. That's our numerator. And we're going to have 1 negative exponent. That's our denominator. That should have been a z. All right. And the other way to look at it is from the very beginning, you can decide where they're going to be. So the very beginning, you can say for my x's, my largest exponent for my x is in my numerator. For my y's, my largest exponent is in my denominator. And for my z's, my largest exponent is in my numerator. So that's going to tell me at least where they're going to end up. And then just check your subtraction. Scientific notation, but this time with division, all right? And so it says in 1998, the total amount of waste paper and cardboard that was recycled in the United States was 35 million tons. The population was 270.5 million. On average, how much paper did each person recycle? So the first thing they did was they rewrote this in scientific notation. So the 35 million tons, we're going to write in scientific notation to be 3.5 times 10 to the 7th. And then the population of 270.5 million, we're going to rewrite as 2.705 times 10 to the 8th. When we are doing scientific notation, we're going to look at it much the same as we did with the multiplication. We are going to divide the number piece of it, that is not the tens, and then we are going to use what we know about division of like bases to do the 10 piece of it. And so for this one, and I'm not going to give you numbers this large, but they divided the 3.5 by the 2.705. And when they did that, they got approximately 1.3. And then we're going to do the piece with the tens. These are like bases, so we're going to say 7 minus 8. So then they got 10 to the negative 1. And so this is already in scientific notation. We have our numbers that fall within the realm of 1 to 10, and then we have times 10 to a negative 1. Now with scientific notation, you leave it as a negative exponent. You don't move it to a denominator position. You leave it this way. And so when you're doing division of 2 scientific notation numbers, you are going to divide the number piece and then use your base like bases to subtract those exponents. So go ahead and try just A and B here, just A and B. And make sure your answers are in scientific notation. For the first one, you're going to divide 2 by 8, 2 by 8. And then you are not going to have it in scientific notation originally. So if you subtract your 3 and your 8, you would get -5. But to put it in scientific notation, you need to move it one more over. So you should have gotten your final answer as 2.5 times 10 to the -6. 2.5 times 10 to the -6. For the next one, you have 7.5 divided by 2.5. You will get 3 there, which was within scientific notation. And then 12 minus a -4, you should have gotten 3 times 10 to the 16th. All right, so questions on either of those division. So in this case, we have something that is already as division inside parentheses, and the whole thing is raised to a power. And so if we were to do this out long, we would basically say x to the y times x over y times x over y, which gives us x cubed over y cubed. And so when you have a group inside, whether it is multiplication or division, you're going to raise everything in that group to that power, which is where we get the next concept here, or the next property. It says for every non-zero number a and b, an integer n, you have a over b to the n equals a to the n over b to the n. They give us the example 4/5 raised to the third power. If you are taking a fraction to a power, you just take the numerator and the denominator to that power. 4 cubed over 5 cubed is 64 over 125. So let's look at example 3. Example 3. They want us to simplify 4 over x squared cubed. 4 over x squared cubed. So we're going to take the 4 cubed and the x squared cubed. When we cube the 4, we are going to get 64. And in that denominator, we have a power to a power. So we're going to multiply those and get x to the 6th. X to the 6th. So go ahead and try those 3. 3 over x squared, and the whole thing is squared. You should have taken each of those to the second power. 9 over x to the 4th. X over y squared cubed. X cubed over y to the 6th. And t to the 7th over 2 cubed. The whole thing squared is t to the 14th over 64. All right, so for this one, we have x, and we're going to raise it to that third power. And then we have y squared, and we're going to take that to the third power. And since this is a power to a power, that's going to be y to the 6th, and the x is going to stay the same. So you can use what you know about exponents to write an expression in the form a over b to the negative n using positive exponents. So what we just did, we would say, well, this a should be taken to the negative n power, and the b should be taken to the negative n power. And we know that when we have negatives, it's just going to move it. So the a is actually going to move to the denominator, and the b is going to move to the numerator. So we're going to end up with b to the n over a to the n. And so what happens with these, if I have a fraction to a negative power, I can just rewrite it as the reciprocal to the positive power. All right, and sometimes that saves you doing a lot of steps within it if you start off with the reciprocal to the positive power. And it doesn't matter what's in it. It can be variables, a combination of variables and numbers. You can flip the entire thing that's on the inside if it's to a negative power. So let's look at example 4. Example 4 has 3/5 to the negative 2. So I can immediately go ahead and rewrite that as 5 over 3 to the positive 2. And then I can do my property there. 5 squared over 3 squared is going to give me 25 over 9. And then you'll see that b has variables, and it's perfectly fine. So we're going to flip it. We're going to say negative y over 2x instead of negative 2x over y, and we're going to raise that to the 4th power. It does not matter where you apply the negative, whether it's the numerator or the denominator. You just need to pay attention to how much you're raising it. If you are raising a negative to an even exponent, it will become positive. If you are raising a negative to an odd exponent, it will stay negative. All right? So I can apply my property here. Negative y to the 4th over 2x to the 4th. For this one, I'm applying two properties. The negative y to the fourth is going to just become positive y to the fourth because that's negative 1 to the fourth power. And then I need to apply that fourth down here to both of those. So I need to say 2 to the fourth and x to the fourth, and then I need to simplify that 2. So that 2 is going to be, to the fourth is going to become 16. So y to the fourth over 16, x to the fourth. So just flipping it to the begin with and then applying your property across the board is going to make it easier. So go ahead and do example 4, all 4 of those. For the first one, you should have gotten 64 over 27, 4/3 to the positive 3. For B, negative 32, flip it and you'll have negative 2 raised to the negative 5th power, or to the 5th power. S over 2r, you just had to reciprocate that and it was to the 1st power. And then m squared over 49a squared. Questions on those 4?